Hello everyone, Bill the Sky Guy here. Well, for the first time in 3 months, we've had maybe 2-3 clear days since the beginning of July, I think it is. We are within 2 weeks of the Mars opposition on October 13th, and I'm getting ready. We've got 2 clear nights, and even though the moon is fairly close to Mars, I'm going to test out my new imaging train setup for planetary photography. I've been doing astrophotography for a couple of years, but with wide field cameras. Just last July, right around Jupiter opposition, I got a couple of nights in there where I was able to use my guide cam, which is a ZWO 120 Mini, as a main cam with a filter wheel, and was able to get a reasonably decent shot of Jupiter and Saturn on my second try. That was nice, but there was a part of the whole thing that was missing. I couldn't get the Barlow lens involved with everything because I couldn't figure out the image train for it all. So now that it's Mars, and this will probably be the best apparition of Mars for the rest of my life, probably. So I figured, well, let's really get some advanced work in on it. So I've got 2 weeks. I'm approaching this like it might be my last time. So this might be the night. Who knows? The weather's been so terrible. So I'm going to put this together. I thought it might be interesting to just go through the entire focus train of how this is all going to work, both for me, and I thought it might be interesting as a video. So here we go. Let's talk about the general differences between doing planetary versus wide field. In wide field, you need a short focal length telescope. 500, 600, 700 millimeters is good. And then you've got a big camera with a wide sensor, and you get your nice flat field of view. Now, in order to get that flat field, you have to have the sensor end up exactly 55 millimeters back from the last optical surface. Now, there's some variance in there, but there's usually spacers and stuff like that. 55 millimeters seems to be the magic number. So you want to plan all of your spacers and nose pieces and all this stuff so that everything gets the sensor to 55 millimeters from the last surface. And the purpose for doing that is to get all the stars nice and sharp from edge to edge in the frame. Well, with planetary, that's not really an option. You're using a tiny little camera with a tiny little sensor, and you're not even using the whole sensor. You're using what's known as a region of interest mode, an ROI mode, on your picture-taking software that just uses a portion of the sensor where Jupiter or Mars or where your planet is, and it takes lots and lots of frames really fast, like maybe a couple of thousand frames in a minute, and orders them up in a movie. So the edge-to-edge requirement and having it be 55 millimeters isn't really as important. So let's start at the image train. We'll start at the telescope end and work backwards. So on my scope, it's a 2000 millimeter Ritchie-Chrétien astrograph, and I have put a moonlight focuser on it. Moonlight makes a great focuser, and it's not as expensive as some of the things that you would get. You can see this is pretty hefty. Now, coming off the back of the scope, there are rings that you screw on. It comes with 2 1-inch rings. This is the one I use, so I'm going to leave it on there. At least I think it's the one I'm going to use. That's my story, and I'm sticking to it. And then there's a 2-inch ring that comes with it. And you can screw these on to get the focuser the proper length away. 1-inch ring has always been the ring, so I'm going to go with that. Then on the focuser itself, you have 2 different kinds of backs. If I'm using the wide field camera, I use the camera back, and basically these are screw-in affairs. And boy, I tell you, if you get these in there, really, really tight, it requires, you can't get them off with your hands. You need pliers, and you can see that I've managed to mark this up fairly successfully with the pliers trying to get it back out. But they do screw in very nicely. And then there's a ring here that you can use to control your camera rotation and all of that. As you can see, I've got a motorized focus control on here, and I just made a video about using motorized focus on your scope. It'd be nice if you could go watch that and give me a like. However, what I'm going to do is there's really no good way to get the Barlow lens to attach to this thing. So it's a larger size than any of this stuff, and it's going to be a problem. Generally, you want screw-in items in your chain along the way, rather than pressure fit items. But for what I'm going to do, it looks like tonight I'm going to have to go with the visual back for the focuser, which drops in here and screws in nice and tight. It's a compression ring design here, and the great thing is you've got 3 tightening rings to apply the compression ring on the Barlow lens, which is going to go in there. Now, I know the folks at Teleview like to call these power mates, but for all practical purposes, this is a Barlow lens. But they're Teleview, and if they want to call it a power mate, they can call it a power mate because they're terrific. And so what we're going to do is they recommend that you take the Barlow apart. So you can do that. The Barlow is constructed this way. The power mate. I'm just probably going to say Barlow for the rest of this, so just hang in there. Sorry, Teleview. So there is a 1 1/4 inch eyepiece adapter that goes on the top. We're not going to be using that. And then you put a 2-inch eyepiece in there, but they don't want you to use that either. So we're going to unscrew this thing, and you're left with the lens portion of this. Hey, boy, I'll be cleaning that before I use it tonight. Anyway, so this now goes into the focuser like that, and you tighten it down with a compression ring. All right, and that's in there very nicely and tight. Now, you need some way to start getting the filter wheel on here. And the problem is that this is not any of the standard diameters that I have for anything. So we need an adapter. So I bought this, which is the wrong thing. Boy, it's so easy to buy the wrong thing. This is for one of the Teleview scopes. They're visual scopes. This is a T-ring for a visual scope. This is for sale if anybody wants it, because I bought the wrong thing. But I'm going to use it for the purposes of this demonstration. This is the right thing.
You have made me very angry.
And that will be arriving from High Point Scientific any day now. But nevertheless, I'm going to use this for the purposes of making the video. So what's going to go on here, this is going to go on the top of the focus. It screws on to where the black barrel used to go. Screws on to where the black barrel used to go. It goes on the top. And then it has on here a 48M ring on the top. All right, so I'm going to put this away now so that we know what that's about. Just keep these things as clean as possible. Okay, so that's going to go into the focuser, and that gets nicely tightened down in there. Boom, like that. The next thing we need to do is we need to get into the scope side of the filter wheel. Now, most of the filter wheels have this nice little nose piece thing that you get with the filter wheel, and that's good for keeping dust off. But we're not going to be using that today. We're going to be using this is a 54, and we need to get to a 4. Okay, so this is a 54M thread coming off of the filter wheel. It's a 2-inch filter wheel, so you need a big hole. And the whole thing is pretty freaking gigantic. So this ring on top here is a 42. Well, we need to get that to a 48 so we can use a 54 to 48 converter. So they make these things. These things are really terrific. This is a ring that has threads on both the inside and the outside. And they make these in a bunch of different diameters. and sizes. This is a 54 to 42 ring. And so what we're going to do is we're going to put this on the top of the correct teleview thing, and we're going to screw it on there like so. And that makes for a nice tight thing. And then this will screw into the filter wheel like that. And that will get nice and tight. Now, these things have to be tight, but if you get them too tight, they're really tough to get off. And of course, this is really two things. So you might end up just unscrewing it and getting one of the two things and the other one is screwed and left behind. This happens to me all the time. If I had a permanent setup, I could Loctite some of these things together, but nevertheless, these rings are really terrific. I've got 3 or 4 of them in various different sizes between 54, 48, and 42, and they will definitely save your image train butt somewhere along the way if you are trying different setups and things like that. So we get that together, that ring goes on there, threads on both sides, we screw it in, and then this, when it's the proper thing, will attach to the power mate, Barlow like that, and we are good up to the filter wheel. Now we have to get the camera hooked up to the filter wheel on the other side. Well, the problem is this filter wheel has a 54-inch hole, and we need to get it down to this is a 1 1/4 inch eyepiece size, this camera. Okay, so what are we going to do? We're going to use this ring. This ring came with the filter wheel. This is a 54 to 48, 54 on the outside there. And we're just going to put this in there like this, very carefully, because there's a filter right there. And this is another one of those ones you don't want to get your fingers on the filter. You're going to get that in there. You want it tight because you can't slip, but not so tight that you have to use pliers to get this out. That would be really dangerous. One slip of the pliers and you've ruined a $300 filter. All right, so the next thing is, what are we going to do now? Well, it's another one of these rings to the rescue. This is a threads on the inside outside ring. This is a 48 to 42. So what we're going to do, this seems kind of hinky to me, but it works. We're going to just put this in, but we're going to leave half the ring exposed so that the next thing can still connect to it. So we just get that in there. Come on. I have performance anxiety. There we go. A few turns, get about half the ring in there. And then we're going to take this, which is a female 48 to a male 42, and we're going to put that over the top of that. This is a standoff ring, and that tightens down very nicely, actually. Next thing up is an eyepiece. This is a 1 1/4 inch eyepiece screw-on adapter that goes from 42 and will now hold the camera. You want this 16 millimeter standoff ring in here because this is another one of those pressure fit things. Yeah, compression rings are great, but you see how much play is there. Even when you tighten it down, you know, it's fairly decent, but boy, it sure would be better if you could get the entire camera in there. So there's a standoff ring here, which I have set for another position. It doesn't really matter. We'll see. We'll tighten this down, and that is a pretty good solid connection. So the full setup here now, let's just go, is the focusing motor, or the focuser with its focusing motor, the visual back. You got this, it goes in there like that. And then this will eventually adapt to that. And that is going to be the image train for tonight. So I hope this works. It worked pretty well when I was just using the regular camera and the filter wheel without the Barlow. Now, let's talk about using a Barlow in a setup like this. I was surprised when I got into planetary imaging just how different the protocol is. When you're doing long exposure deep sky astrophotography, it's all about getting perfect polar alignment, which is always good, and opening up the shutter for 5 minutes at a time, 3 minutes, a minute and a half, however long you can do without getting streaky stars. Planetary astrophotography is a completely different procedure. Yeah, you still have to get all this stuff together, but you end up taking movies of the planet through each filter. Essentially what you're doing is you're taking this camera. This camera has a USB 3 connector on it. And a USB 3 connector is capable of sending some serious data at you. If you've got the connection and there's no bottleneck in the way, like a hub or something like that. So I'm going to take a USB 3 cable straight from this camera to the computer. And the Fire Capture is the program that I use for this. Fire Capture is going to set a region of interest big enough for Jupiter, Saturn, or Mars that takes this chip, which is 1920 by 1080. That's a full HD chip. This chip was only 1290 by 960, or 1280 by 960. And when you've got it looked pretty good, but when you got the image up on your screen and enlarged it a little bit, you started to see pixelation. So I'm thinking that this chip being, a good third larger, with smaller pixels. The pixels on here are 3.75 microns. These are 2.9. So it's a third larger chip with a third smaller pixels. This is going to give me a pretty good bump in resolution. Based on my experience, I expect to be able to, once I have this thing in here and taking pictures, I expect that the transfer rate will allow me to take a minute long set of exposures, which should be about 2,000 images of Jupiter in a minute, based on transfer rates. I'll figure out whether or not that has actually happened. It's all subject to lots of different things, but you don't take a full sensor read. You just trim down to what you need to get Jupiter in there with a little bit of play, because your mount's not going to be perfect. And then you blast off 2,000 images or a minute's worth of exposures as a movie of Jupiter and the red filter. And then you switch the filters and do it again right away, because Jupiter is spinning fast. So you do the red, then you do the green, take another 2,000, and the blue. And you don't want to just do that once. You want to do that like 10 times. So the whole thing is going to run you, it's going to take you about an hour to get through it. You're really trying to get those momentary little bits where the atmosphere is not really making the image boil. When you look at it on your screen, you're going to go, oh, this looks terrible, right? But if you take 2,000 frames in a movie of each filter, you then load it into the processing program, which is Auto Stackert 2, and it will go through and analyze each frame of the 2,000 frame movie and reorder the frames in the movie so all the good ones are up front and from best to least. And everybody uses a different amount. I like to use somewhere around 10%. I think if you can use the best 10%, 12%, something like that, you've got enough frames that you have enough smeariness for your noise reduction and all of that, but you're not including any real dogs in there that are going to smear up your image. So you can usually find a good 10% of one of those runs. So if you do 10 runs of a minute each on each filter, I do have a luminance filter in here. I tried using it last time. It didn't really need it. The image was plenty bright and it didn't really add any detail. It just kind of washed things out. So this time I'm just going with red, green, and blue, and make sure I get good exposure, 75% exposure, 65, 75% exposure on each filter as I set it up. And I'll just be changing the filter, blasting for a minute, change filter, blast for a minute. It's going to be fun. So I'm looking forward to that. Okay, here we are. It's about 1:30 in the morning, and I've been shooting Mars lately, but Jupiter and Saturn earlier. I really didn't get to Jupiter and Saturn until they were well past the meridian. And that's the moon and Mars right there. And the moon's going to be right on top of Mars on Friday. So this is kind of like it for until next week. Here in the software area, we're working fire capture. And I still have PhD 2 going. It helps with pointing some things. And then I've got sequence generator where I have to switch the filters. It's kind of an interesting, weird thing how fire capture technically can control the filter wheel for you, but it does it wrong, or it doesn't do it at all. It goes to the wrong thing. I haven't been able to figure it out, so I just switch them manually, and it keeps me involved. Anyway, so we just did the blue. So I come over here, manually set for red. And then the way fire capture works is you've got a different setup for red, green, and blue. Each filter has its own setting of gain, exposure, and USB traffic. And I've got it set for 90 seconds. And at 65%-ish. And you just hit record. There's the running time. The bar changes color, showing you which one you're on, red, green, or blue. Haha, nice. There's some options down here. The focusing thing has been fun to deal with. But so I started the night on Jupiter and Saturn with the Barlow lens in. And it was a boiling blob of crap, both Jupiter and Saturn. But I shot minute-long exposures and was able to get about 1,200 exposures in a minute. My frames per second is 15. I shot 4 or 5 runs of Jupiter and 4 or 5 runs of Saturn. You know, a minute of red, a minute of green, a minute of blue, and did them both. And they were pretty low, and I didn't expect them to be very good. So then I put the telescope on Mars with the Barlow and used the focusing routines in Sharp Cap, which I had never used before, but I think I understand them well enough, then they were telling me good things. So I was happy about that. And I came back, and even still, Mars just looked terrible. I mean, you could imagine there would be one frame that would be decent in the entire thing, but apparently there were. It's a large target. Okay, switching to green. And set. Moving. Back to here. Choose the green setup. All of the settings change. Exposure's 2.5 times as long than with the green as it is with the red. Well, it is the red planet. And here goes green, 90 seconds. So I shot maybe 5 90-second runs on Mars with the Barlow in. I just can't imagine what it looks like, that it's going to find actually some crisp frames. In 90 seconds with the region of interest capture area on, I was able to get about 2,400 frames. So, just on a lark, Mars is crossing the meridian right now. Just on a lark, I decided to take the Barlow out and just shoot with the camera looking straight through the filter wheel. I had to change the focus by 10,000 steps. It was 12,650 with the Barlow in, and it's down to 2,991 now. So, had to experiment with all of that. And I thought, well, Mars is going to look a lot better when I take the Barlow out, because, I mean, that's a 4,000 millimeter telescope at that point. You know, maybe it's just not that good. And so I took the Barlow out, and it still looks like absolute crap. Well, my Jupiter pictures did, and they came out okay. So we're just going to see what happens. I'll post them after I get some processing done. So in 90 seconds, I've been getting frame counts in the neighborhood of 3,700. So, boy, if I could get 100 reasonably crisp frames out of 3,700, that might be the thing. So, looking forward to that. Okay, well, last night's imaging session was a complete and total failure. Not a single usable image in the bunch. Hours invested.
Made me very angry.
Well, after a long evening of changing filters and pushing the go button in fire capture, it appears I have very little to show for it in terms of photographs to display. Here's a photo of Jupiter using 8% of the best frames. This is with the PowerMate in the imaging train. So it was a 4,000 millimeter focal length, and by the time I was ready to shoot, Jupiter was a little lower in the sky than you would really want. Here is Saturn, slightly higher in the sky, but with the same setup. And here is Mars with the 4,000 millimeter setup and the non-PowerMate 2,000 millimeter setup.
Isn't it delightful?
Clearly, in spite of my best efforts, I don't have this under repeatable control yet at all. But since we learn more from our mistakes than our successes, I'm going to put this dumpster fire of an imaging session out there and see if I can get these problems understood and vanquished for Mars opposition on October 13th. I would also welcome any suggestions from viewers as to how you saw these problems.
Oh, goody!
First, is there anything good at all about these photos? Well, the PowerMate images are nice and large, but obviously these are not the images to use to tell if there's a trade-off in clarity between PowerMate and non-PowerMate shots. Even with the PowerMate, it seems like a reasonable amount of detail will be there if I can get it in focus. The higher pixel density and smaller pixel size on the camera sensor definitely help with resolution. The color on the Mars shots looks like it's going to be okay after processing. However, Jupiter and Saturn have a magenta tinge to them. Did I get my exposure percentages higher on the red? This didn't happen last time with Jupiter, but it did on Saturn. It's a different camera this time, but since it's monochrome, that in and of itself shouldn't affect color. I'll be more vigilant about matching exposure percentages across the colors while shooting. Well, it seems like the catastrophic failure here is in focus, which is always a struggle, but with planets it's doubly important. It pains me to admit this because I just posted a video about motorized focusers and how to make them work for you, but I failed miserably last night in that part as well. It's not that I wasn't concerned or trying to get it right. There were some odd things that happened that I hadn't run into before, and my diagnosis of the problems and therefore the solutions were ineffective. So let's dive into all of that. Step 1, polar alignment. Went very well. I used drift align and was getting better than 1 arc-second guiding performance. Step 2, collimation. Very important. I was losing Jupiter and Saturn in the west, so I decided to go with whatever mirror collimation was present from the last time, since they were not my main target for the night, and collimating can take a while. I collimated the last time I used the scope, but it's a completely different imaging train now, so I guess there's no guarantee. There's a new camera, mostly new spacers and adapters. There was a PowerMate in there, and not with the right adapter on the top either. I did recollimate between Jupiter and Saturn and Mars. There was a window of time there, and sure enough, collimation wasn't great for the earlier targets. I was also at a 4,000 millimeter focal length, and I suspect that that would reveal collimation issues more readily. Is that true? Anybody? Step 3, actual focusing. I really wanted to use the autofocus routines in Sequence Generator Pro, but first you have to get reasonably close using manual methods. So I found the star Altair and used the batten-off mask and was happy to find out that focus was reachable with this new setup without having to change the spacing rings coming off the back of the telescope. My focus number was initially 12,720, and I gotta say, it looked like I nailed it. The mask image looked perfect. So I slewed the telescope away from Altair to a field with some stars, intending to use the autofocus routine in Sequence Generator to touch it up. Here's where it got weird. Not having worked at 4,000 millimeter before, I wasn't sure, but intuition was telling me that my step size between autofocusing sample points would need to be smaller. I had been using a step size of 110 on this scope with the wide field camera, but the previous week I had gotten excellent autofocus results on my refractor with a step size value of 35. But that was a different focuser, different scope. So I tried 35, fail. I tried 25, fail. 10, fail. And then I noticed that the HFR values I were getting were unrealistically low and saw that the autofocus routine was counting hot pixels as stars. I knew that there was a setting for setting minimum star diameter in the autofocus options screen and tried settings up to 20 pixels, but it didn't really seem to help. So I thought about the source of the hot pixels in the first place, the camera, and tried lowering my camera gain setting from 100 to 60 to as low as 20. No effect. They were still fooling the autofocus routine. I don't know if any kind of display histogram stretching games would affect whether hot pixels would show up and now be counted as stars. Anybody know that? Sequence Generator Pro fans? In retrospect, the real solution might be to apply dark frame subtraction for the purposes of autofocus. There's a provision for this in the autofocus options box. What I really need, though, is a bad pixel map, and that kind of thing is generally associated with dark frames, but there's no mention of bad pixel maps specifically in the manual for Sequence Generator. But right then I was crunched for time because Jupiter and Saturn were slipping away. The smart thing to do would have been to just call Jupiter and Saturn a loss for the night and spend the time shooting a dark library for the camera. It's not a cooled camera, so I don't have to deal with the temperature the frames were shot at. The manual says the dark library needs to have dark frames within plus or minus 2 seconds of the range of exposures you might use for autofocus exposures, which could go as high as 30 seconds for a deep narrowband filter that's, so that's a lot of darks to shoot. You can bet I'll have this together for next time. There's also a high-speed download option for autofocus frames in supported cameras, but the manual warns that this can sometimes introduce noise, which is the exact thing I'm trying to get rid of, so I'm going to turn that off. So I think I should also try the focus target option. One of the hard things about focusing on planets is they're so bright that if you increase the exposure time to try and get some of the dimmer things in the frame to show up, like stars, the planet blows out so much it takes over most of the image. Sequence Generator has a tool where, after you've found your actual target, which you mark as your shooting target, you can also slew away to an area nearby that would make a good focus target without your planet in the frame, mark it, and then switch back and forth. This would have been a good idea too, now it seems. Damn, hindsight is a bitch.
Isn't it delightful?
So I ended up abandoning autofocus. If I take all those steps, I think I can get it to give me repeatable results next time. I slewed the telescope to Jupiter. It was a little hard to find with the truly tiny field of view with that camera, so I relied on the guide cam mostly. One thing about Jupiter, you know when you found it. I eventually found Jupiter in the main cam and then adjusted the aim of the guide cam to put it dead center when Jupiter was centered in the main cam. I checked focus and was expecting better based on the results I got with the mask. It was a boiling blob, which I was expecting. Here's what an in-focus live view of Jupiter looks like with 2,000 millimeter focal length. That bubbly mess produced this photo. Actually, now that I see it again, another mental error I made was remembering this movie to be much less in focus than it actually is, which allowed me to believe that tonight's session might be okay. I'll chalk that up to lack of experience, since this is only my third or fourth attempt at a full-on planetary imaging session. Jupiter's moons make a pretty good focusing target, and I wasn't thinking they looked like a best effort, so I did some focus adjustments with the motor and was able to get 2 of the moons to sharpen up a decent amount. My focus number had changed to 12,650 now. I even tried putting the mask back on the scope to see if I could get the mask pattern on the moons, but it was inconclusive. However, by now Jupiter was getting pretty low in the sky, and it could just have been atmospheric turbulence. I had no way of knowing. In retrospect, I think I should have tried a wider range of focus numbers, looking at the entire image, making sure to try and get the edge of the planet as good as I could. But even when it's perfectly in focus, it can still look like a boiling blob, so it's really hard to tell when you've got it or you're just chasing your tail. Since I was unsure about focus, I launched SharpCap since I was interested in trying out their focusing tools for edge detection and background contrast. I thought I understood enough about these tools to interpret the results properly, but as it turns out, I don't. I need to do more reading about this in the manual and see if there's any YouTube tutorials out there. So I shot a bunch of images, 60-second runs with red, green, and blue filters, hoping for the best. As I think about it now, it really doesn't take all that long to process one of these sets of movies, so it wouldn't be a bad thing to launch AutoStacker 3 after the first run of RGB and have it look at and analyze the images in the movie and see what the quality graph actually looks like. Mine looked like the zigzag on Charlie Brown's sweater instead of the higher scores at the beginning of the graph that you want. It only really takes a couple of minutes to align and stack a test image, and this could have saved the night. Here's how all that works. Okay, everyone, here I am in AutoStacker, just to prove to myself that you can quickly use this to help determine whether or not your final product is going to be in focus or not. So I've loaded up one of the files. I use the .ser file format. I don't know what that stands for. It's a new one for me, but it seems to work. I'm not asking any questions. So I've loaded up one file I would have shot. This is the red channel, although it doesn't matter. And we want to use a quality estimator thing. This is new, but it looks like it's the thing, so I'm going to go with it. I'm not an expert on this program by any chance, but it should be fast. So you want to go through and just hit Analyze. And it looks through the entire movie.
Oh, drat these computers. They're so naughty and so complex.
And looks for the best frames.
I could pinch them.
And then reorders the movie so the best frames are up to the front. And then you get a quality graph. And the higher this graph is, the more quality frames that you have. So you look at the green line and see how many really, really good frames you have. Obviously these are not so good and the quality drops off. But you look up here and the green line says that, you know, the first 10% of frames are okay to stack. So maybe how many frames total do we have here? We've got oh, you can just do this and it shows you that there are 1,082 frames in this movie. So 10% of those would be good. You can just do the total number of frames and it'll give you 4 different choices and say 4 different stacks with 4 different frames. So if you wanted to try 10 frames, 25 frames, 50 frames, and 100 frames, you could do that. Or you can do it by percentages. To me, this looks like if you just wanted to use the best of the best, I don't know, maybe you could go with, some people recommend 10%. Let's do 10%. That would be about here. After you've selected 10, actually, let's try 3% here and 10% there. And we're going to have it make a stack, one of 3 and one of 10%. In order to get the stack button to be ready, you have to place alignment points over here. So I'm just going to, doesn't really matter. That's enough alignment points for the purposes of this test. And then once you're ready with that, we'll leave drizzling off for now, although I would typically turn it on and it would save a drizzled and a non-drizzled version of this. And then we hit stack. And it goes through and makes a TIFF of it, which looks like that. And you could zoom in on this and see whether or not that is the 3% image. It's a little soft, but everything's there. And here is the 10% image. Well, it'd be interesting to compare those side by side, wouldn't it? Try and get them the same size. So that's 3% over here, 10% over here. Certainly there's enough information there to tell whether or not you've got a decent enough focus. Saturn. It was the same thing with Saturn, but a little more encouraging since it was a little higher in the sky and has a more complex shape, but ultimately another big waste of time. Well, after taking a good 15 to 20 minutes to touch up collimation, Mars was approaching the meridian and it was time to get busy. I shot 90-second movies of red, green, and blue for a couple of hours, all garbage. Think of all the hard drive space I'll be getting back.
Back to the old drawing board.
Towards the end of the session, I was still not convinced about focus, so I decided to shoot some runs without the power mate to see what that would look like. Of course, I needed to refocus again, and my new focus number was 2,991. But somehow I made the same process mistakes and didn't get it any better, which is very troubling to me. Note to myself, call my astrotherapist. Well, I hope my going down in flames on this has proved to be illustrative and outlines my approach to problem solving. We'll see what happens next time, which hopefully will be next week sometime, the week before Mars opposition. I welcome any suggestions from the community and any magic bullet tips you might have about planetary focus. Until then, this is Bill the Sky Guy saying, Carpe Noctem!
Where's the kaboom? There was supposed to be an earth-shattering kaboom.